So the topic we are discussing now, it's the modular programming, and you will notice we have the PowerPoint presentation in Connect. Then we have exercises and files. As mentioned in the previous session, files is just a PowerPoint review what we have discussed in the last unit or the previous unit about programming also. So it's a good idea to go through this one after we finish the delivery of the modular programming, review what is there, refresh your memory. We all human beings, we can easily forget things. It's fine if you forget things. We all do so. So please just refresh your memory. If you have a question, drop me an email or discuss that during the class time with me or on Discord. We have lots of channels to communicate in addition to the exercises. So modular programming. Before I start anything in modular programming, let me explain the idea in a simple way. So this is the PowerPoint. If for example, I need to create a document or create my CV, after you graduate and you get the certificate for, you need to update your CV or create a CV. And to do so, we will use, for example, Microsoft Word. So when I open Microsoft Word and open just a blank page like this one, so you notice we call it Microsoft Word. It's one app. When you check its size on the hard drive, maybe it's like 2 GB of data. Lots and lots of files. So what are all these things? In fact, because it's a huge application, it does lots of things and functionality. It's packed with lots of features, So we divide that into smaller items. For example, we have a printing function like this one. So we click and this will call the printing function. It will call the printing part within Word to print. It will start the module related to printing. We notice also we have some icons there. Each icon will do specific simple job. For example, converting text into bold, italic, underline, copy and paste, save as, attach with email, and so forth. So all of these functions, each of them is a small module. It fixes a small problem. It gives us a small functionality or feature of the application, of the huge application called Microsoft Word. So this is the whole idea. If your application is getting bigger and bigger, you can't do everything alone. So you will need multiple teams, and you assign a team for each function so they can work on this function, create a better one, fast one, accurate, maintain the issues, maintain the security, and so forth. So this is the whole idea of the modular programming, dividing your application into smaller modules, and then we can call them. So here, this is the explanation of what I said. Too many nested blocks of code. If we have a huge application, too many variables. So we need to break these ones into smaller modules. We can give it different names. Sometimes we call it a procedure, method, function, class, package, and so on. So in Windows, we call these ones dynamic linked libraries, DLLs. In Linux, we call them shared libraries.so files. So these are the shared libraries. After that, we test each module and make sure each module is working fine. There is no bugs. It's secure when it runs. If there is an error, it will exit safely. It won't hang as much as we can. Then we link them together, and will make the application also working faster, because in our example here about Word, I don't need to get the check spelling functionality up and running now, but when I, for example, go to review and click on spelling and grammar, or press F7 from keyboard, this will call the function, call the module. It's a file stored on the hard drive first. Then when I click this icon, it will come to the memory and run. At the moment, it is not in the memory. It is not running there. It is not taking any performance. It is not taking any space from the memory. But this makes the application runs faster because we don't call all the modules at the same time. All the components are not running on the memory at the same time. Did that make sense? I hope it makes sense for everyone. So we will never load everything to the memory. We will load whatever we need. Then we can, this way we can have better performance from the application. Okay. Also, breaking down the big application into smaller parts will help us to solve the problem easily, bit by bit. We can work top down or bottom up. Top down, we start from single problem, then go into smaller problems. The bottom up will go from the small problems to the big one. After all, we will use this imaginary figure to think about how we will decompose the big problem into smaller ones, the difficult problem into minor ones, and the easier bits and pieces that we can handle easily. So if the problem needs to be decomposed again, and we break it into smaller pieces, we need to do so. So we will do it. Otherwise, we will just work with the small one, like making the text bold. But here, maybe printing, then under printing, we need to know how many pages, double face, colored ones, and so forth. So we have different functionality through the printing module. So bottom-up design and bottom design. So top-down design and bottom-up. So both of them using almost the same figure, because the idea is decomposing the big one into smaller ones. Whatever in reality, in fact, we use both, and most of applications we have, they include large amount of modules, dozens or hundreds. Think about Windows. After all, it's an application, it's a software, or Windows Server. So we have different components there. Then we have definition of the module from Wikipedia. So the definition is important to go through it. So it is a self-contained component of a system which has a well-defined interface to the other components. Something is modular if it is or if it includes or uses modules which can be interchanged as units without disassembly of the module. So design, manufacture, repair, etc. of the modules may be complex, but this is not relevant. Once the module exists, it can easily be connected to or disconnected from the system. So that was the first idea we have here in the modular programming. We will decompose and break down our big program into smaller parts so we can manage them, handle them, improve them. Then we link them together and call them one by one. The other point is the interfaces. So for example, I want you to visit me. I will text you my address. Once you touch my address on your phone, it will open in Google Maps or Apple Maps or whatever maps application you're using. So there is an interface between the Messages app. It could be WhatsApp, Messenger, Zoom, anything. Then once you click on the link, it will open another application and start showing you, for example, the map to my house so you can drive and visit me. We call these interactions or gates or exits between applications, we call them APIs. So different interfaces, and all of the applications and systems, they have APIs. So here we separate the interface from implementation. This will make it faster, easier, and make the system available to interact with, exchange information with. So let me show you. So we can have different APIs to different systems. We are using here Google Maps API, so developers.google.com, Facebook API, so developers.facebook.com, Twitter API, it will be developer.twitter.com. So here, even the big systems or websites, they have APIs, so we can create some applications that can deal with these APIs, read and write, interchange and exchange the information between our system and the other systems. So this is the idea beyond the application programming interface or API. So if, for example, you want your application to print on the printer, so you need module for printing, then this module will be the interface between your application and Windows operating system. Then Windows cannot print on the printer without also another API with the printer driver. So we will have 2-3 systems involved between you click on print, then the paper is printed as a hard copy on your printer. So this is the second idea we need to understand. In our applications, we will have APIs. So modules and APIs. The benefits of the module that we can reuse also these modules. So if I have a printing module created in Excel, I can use the same module in PowerPoint, in Word, in any other Microsoft products. We can use the same module, and we can call this module to execute the printing. That makes sense? I hope so. If you have a question, please put it on the chat. So when you write modular programs, you will think about the following questions. When you design a big application, you will think about the modules you need to write your program. Do you need to print? Do you need to save to hard drive? Do you need to read barcode? Do you need to connect to Bluetooth? Do you need to barcode or QR code, read this one? Do you need to have APIs to maps, for example? Do they already exist as part of the system? You need to integrate if the printing module in Windows. So maybe I don't need to rewrite everything. I will just get a small one from online, insert it in my code, then communicate with Windows printing modules and drivers. So can I obtain modules to provide me with functionality instead of writing them myself? Yeah. Do I need to create the save as or save or format your text into bold or italic? Do you need to write this one, or you can just get some modules from online and embed them in your code and test them, of course. Of course, you're getting the open source ones. For the modules that already exist, where is their API documented? Is it a good API? Or you need to write your own code? How you will create the modules? How can you design good API for your modules and reuse them? Okay, so here we have some functions, and it's telling you to work on these functions as a class activity. I prefer you go into the exercise. So for the second topic, we have how many exercises? We have 7 exercises. So once you finish the first one, you can start working on this one. I prefer you finish the exercises before next week. So today and tomorrow, we will cover a few topics. Then you can do the exercises for these topics, share them on Discord, send them to me by email, or we can discuss them during the class time. There is no problem at all. So we have few exercises here. Again, it's a really good idea to go through them. I prefer also you try yourself, make mistakes. It's fine to make mistakes. You will learn a lot from mistakes. And if you forgot anything about Python, you have the book. We have the book and the YouTube channel for automate the boring stuff. In addition to, we have the Discord and emails and everything. Okay, does that make sense? Okay, any questions? I'll stop the recording now and stay online for quite some time if you need to ask me something. Again, thank you for coming on time and your efforts. I hope also this unit, it is not that hard. It's an easy one. And already I'll go back to the unit here just to show you what we have as assessments and the quizzes. So we have the assessment task 1. So someone submitted that already. And we have also 1 quiz. So total of 2 assessments. So assessment task 1 and 2. Some people already submitted that. Yes, class is running in this pilot period on Mondays and Tuesdays only. There is no classes on Wednesday or Thursday or Friday. Okay. Good.